Okay, welcome back, ladies and gentlemen. Today we're going to be taking a look at our last and final review for circles and tests and whatnot, and our test is again going to be tomorrow. So this review that we have handed out to you guys has a bunch of different various things on it. Some of it has to deal with arc length, sector area, things like that. Let's kind of work our way through it and see how we do, okay? So the first question says area and circumference, and we will be giving you all the formulas. So pi r squared is your area, 2 pi r is your circumference. We're going to ask that you use 3.14 for pi. Alright, so if you can do that, that'd be great. If you use the pi button, we're not going to hurt you. It just makes it easier for us to grade. So here for this first problem, all I'm concerned with is my radius, the first part. So my radius is 5. Sweet. How can I find my diameter? Well, double it. We get 10 inches. Okay? Now, as far as circumference goes, it's 2 pi times r. Make sure you're using the correct one. Times 5. Alright, which is approximately, if I have my calculator here, 2 times 3.14 times 5. 31.4. And then we're talking about inches here. Okay? 31.4 inches. Let me see if I can zoom in just a little bit. Maybe that'll help you guys. Okay, now for area, it's pi r squared. Alright. My radius again is 5, so it's pi times 5 squared. So it's 3.14 times 5 squared. 78.5 inches squared. Please be careful, everyone, for your units. I know I've stressed this with the arc length and with the area of a sector. It's inches for circumference. It's inches squared for area. That's across the board. All right. I'm going to show you just one of the next two, just because they're basically the same problem. The pictures up here, they're just there. They're not going to hurt you if you look at them. But this time they're giving us diameter. Does that mean my radius is 8? I'm hoping that you guys are all nodding your head no. But for the radius, it's half of my diameter. So you're taking 4 and dividing it by 2 inches. All right, and then we're doing the same thing. 2 pi r for circumference, 2 pi times 2. Okay, this is all calculator work. Please use the calculator. 12.56 inches. And then my area is pi r squared, so we're looking at pi 2 squared, which is going to be, let's see here, once you know it. Hopefully some of you guys can see this already. Same thing, 12.56. Okay, but this one's inches squared. Yes, that's possible. So please don't panic on that one. It's all good. Just to show you guys, next one's super quick. 6 inches, because it's half. Circumference is 2 pi r. 2 pi times 6. 37.68 inches. And then for the last one is pi r squared. So 3.14 times 6 squared. 113.04 inches squared. Alright? Wonderful. Okay, very, very nice. Looking good. Okay, so now on to arc length. So find the arc length. It's up top. Again, we're going to give this to you. It's going to say arc length is this. Okay, so central angle is the angle they give you. In this problem, I know it's hard to see because it's kind of blurry again. It's 285. So 285 divided by, 180 times 3.14 times my radius, which is 12. Guys, this is strictly calculator work. So now, I don't know if this is in your way or not. I'm assuming it is. Give me 1 second. Okay, cool. So I'm going to do parentheses 285 divided by 180. Close it, times 3.14 times 12. Pardon me. 59.66. And this is meters. Because it's arc length, it's just meters, just done. Okay? Please put this line down, just for your own sake. The reason I'm saying that is it's very easy to make a little mistake on the calculator, but by you writing this step out, you are helping yourself out immensely, okay? So it just makes your life better, okay? Because I can give you partial credit if you do that. Next one, same idea, 90 over 180 times 3.14 times 13. Okay. So what we got here is parentheses 90 divided by 180 times 3.14 times 13. We get 20.41 inches, and again, it's just inches, not inches squared. Okay. Now, oops, I want to get rid of that completely. We're next going to be taking a look at some sector area rather, which the formula does change a bit. Okay, so it's basically the same thing. Here's my formula: central angle over 360 times pi times r squared. Central angle 60 over 360 times 3.14 times my r is 10 squared. Okay, so this is all calculator work. Parentheses 60 over 360 times 3.14 times 10 squared. Okay, 52.33. I will say this: if it's a repeating decimal, and by the way, what decimal would that be, or what fraction would that be? Hoping you guys all know it's 1/3, 0.33 repeating. You can just round the 2 decimal places. Okay. Now in this case, it's in miles. It's a really big circle. It's miles squared. Okay. So boom, boom, we all good. Same idea over here. I don't want to show that all the way up. Let's see here. I'm blowing up over here. 270 over 360. Kind of a popular guy, in case you guys didn't know that. Times 3.14 times 5 squared. Parentheses 270 divided by 360 times 3.14 times 5 squared. So 58.875. If I want to round that to the second decimal place or 100th decimal place, 0.88. All right, yards squared. Okay, wonderful. So first page complete. On to the back. Now it says here, this is actually a good problem. The curved part of an anchor is the shape of an arc of a circle which has radius 1.2 meters squared. Or sorry, meters rather. Calculate the length of this arc. All right, same thing. You're coming back over here to arc length. So you have to be able to read the problem. You can say it says the length, so it's not the area. All right. So I'm doing 85 degrees over 180 times pi times my radius, which is 1.2. Okay. So it's just as simple as reading the problem. Make sure you're answering the question correctly. 85 over 180. Ooh. Times 3.14 times 1.2. We get 1.779, so 78 meters is our arc length. Okay, so the curved part of that anchor would be 1.78 meters. All right, very good. Again, please get in the habit of showing that first line. It's going to help you immensely in your test, and that's the reason for it. It just gives you extra points. Okay. A pendulum is 45 centimeters long. When the pendulum swings, it travels along the arc of a circle and covers a distance of 27.5 centimeters. Calculate the size of the angle through which the pendulum travels. Now, for this one, okay, it's a little bit different, and this one's going to require you to think a little bit. Here's my surface area, my arc length formula. Arc length equals central angle divided by 180 equals 3.14 times radius. Okay? They're telling you what the arc length is here, 27.5. So I'm going to put that in over here. I don't know what the central angle is, so I'm going to put X in for it. I know 3.14, and I know my radius is 45. Okay, so notice how all I'm doing here is I'm just missing something in the middle here. So I'm going to multiply these two things together. I'm doing 3.14 times 45. This gives me 27.5 equals X over 180 times 141.3. Okay, well I want to get rid of the 141.3. I'm going to divide both sides by that. So 27.5 divided by 141.3 Gives me a very large decimal. Now I'm going to fair warn you guys. I know I told you to round to your 100th decimal place. That should always be for your answer. I'm not at my answer yet. I'm midway through my problem. Why would I not want to round right now? Hopefully you guys have learned from before. If you round in the middle of your answer, it throws off your final answer by a good bit. So I want to keep this right now, okay? Because I have one last final step to do here. To get x by itself, I'm being divided by 180. What's the opposite of dividing by 180? Times by 180. Okay? So I'm doing this whole thing times 180. And there I got it. X equals 35.03. And this is degrees because I'm talking about my central angle. Right? This is a challenge problem. Expect something like this for maybe the last problem on your test. It's nothing too bad. As long as you set it up, you're getting some partial credit. Okay. If this is a little confusing, rewind the video, just watch it again. Okay. Down here to inscribe and central angles. Let's take a look. You guys have been doing a very nice job with this. Basically, you have to be able to identify, though, what a central and an inscribed angle is. The central angle goes to the middle of my circle. Boom, 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 boom. Top four are all central. The bottom four, please note how they all go back to the back of your circle. These are all inscribed. So central is pretty simple. If I want to find x, it's the exact same angle it's out here. So x equals 167 degrees. Please don't overthink that. Okay? I wonder what the arc length is for right here. Because it's central, my x is just 139 degrees. Oh no, difficult. 113 degrees, and my x is in the middle, so it's exactly the same. 113 degrees. And then, oh no, it's getting harder. Just kidding with you. 171, you're splitting it, or just the same exact angle on the outside, 171 degrees. Okay? These are central.
Mike, please call the office. Mike, please call the office.
I almost fell on my chair. Okay, so that is just when it goes to the middle. All right, now we're talking about inscribe. This is the one where you times by 2 or divide by 2. Now, how do you know when to do what? If you're on the inside with a number, to get to the outside, you just multiply it by 2. 192 degrees. Okay? The outside, wherever it may be, should always be bigger. So please note over here, this is on the outside. I want the inside. Just divide it by 2. 62 degrees. Okay. What does this little box mean? Hopefully you guys are cool with it being 90. To get to the outside, we're just doing 90 times 2.
Mike, please call the office. Mike, please call the office.
I guess Mike didn't call the office yet. Okay, so that's 180. And lastly, 78 divided by 2 gives me 39 degrees. Alright, so ladies and gentlemen, I'm going to make another video up. They'll probably make it during my planning period today, which will go over this bottom part and the very last few problems. If you have any questions, please feel free to ask. Check out all the previous stuff. You're going to rock out, okay? The more work you can show us, the better. You can bring your theorem sheet with you for the test, and the rest of the theorems that are not on there, I will put on the front board for you, okay? We want nothing more for you to succeed. But please make sure you're putting the time in order for that to be capable of doing, okay? Most importantly, very important, please don't forget, all right? And just take this to heart. Good luck. We're all counting on you.